these gentlemen talk and share a little bit about the first AI supercomputer for community. So we've got 3 gentlemen from Trace 3. This is Matt and Doug and Josh. Yep. And also, this is a pretty interesting project. So we're going to have, hopefully it'll be a nice interactive session. This is it's a collaborative initiative that Trace 3 is working with both industry as well as academia. On the academia side, Dr. Fahey, that's with us, the treasurer, is over at Chapman. They're involved with this as well. On the commercial side, we have actually one of the collaborators is the CEO Leadership Alliance. We have Jasmine and Christina here. Right? Yeah, so they're also collaborating with them on this. So this is an interesting community effort. So with that, I'm going to hand it over to these 3 gentlemen, and enjoy it.
Thanks for having us. Really appreciate it. My name is Josh Lindstrom. I'm Managing Director of Data and Analytics at Trace 3. We're a local IT solutions provider. We've been in Orange County and Irvine for about 20 years. Doug Sayles and I have been working together for about almost 5 years now together in regards to building out the overall practice around HPC, HPA, AI, machine learning, LLMs, Gen AI, all the good things, data and analytics. But from our standpoint, I just want to talk a little bit about how we got introduced to the Chapman University. We are a top-tier NVIDIA partner. NVIDIA came to me and called me one day. I was actually had my dog at the vet, and I got a call from Keith. Keith's their VP, and he asked me, he said, would you be interested in going after and helping build out a community supercomputer? And I said, well, what does that mean? He said, NVIDIA is willing to go donate some gear, in this case DGXs with GPUs, and would you be willing to work in collaboration with Chapman University? So we met Brett's back there, and the team, and Michael, and we sat down with them, and the first initial phase, and Doug's going to get into a little bit more deeper, but the first initial phase was to go figure out and see if the data center was able to go harness all this power that NVIDIA was so gladly donating. And a lot of the times when we talk to customers, the biggest challenge is, do we have enough power and do we have enough cooling? Because a lot of these systems take a lot of that, right? And so went down, did an assessment, worked with the team, worked with the CLAOC, who has been essential to this. I think ideally in collaboration with them, what they want to do is they want to be able to start driving internships and talent coming out of all of the universities. So as a community outreach from a Trace 3 and a CLAOC plus Chapman University, we feel like this is a great opportunity to provide a supercomputer where students can actually build models and really drive outcomes. And what's interesting is with all the stuff that Doug's going to talk about, the in-depth aspects of all the key components and all that type of thing, we're starting to reach out to the County of Orange. We're starting to identify use cases in there that we could go bring to the supercomputer and start leveraging that as like an overall system for not only the county, but the city. And then you start tying in the universities, and that's where I think in collaboration with NVIDIA, NetApp, Doug's going to touch a little bit on a technology called Run AI. We're building out a supercomputer cluster that has the aspects of being able to go touch a lot of things, not just within the university, but outside the community. And we're big proponents of it. All they asked, Doug, I think, was for our time. And so, but we were able to go reach out to our collaboration within Dell. Dell was able to donate some things. We were actually asked, like I said, we reached out to some of our software components. You're going to see some of those pieces as part of this, and reach out to say, hey, what are you willing to donate to this supercomputer, because we feel like it's going to be a necessary need. CLAOC is really cool because they are trying to make Orange County the AI Center of Excellence. And so that's one thing that Trace 3 and my team, we stood up and we said, we don't care what leadership says, we're going to invest our time. So we've been doing that the entire time. Can't thank enough without all the partnerships and all the technologies that Doug's going to mention. But ideally, I think this is a really strong use case in regards to how organizations are looking at this, and Doug's going to go drive that. So, Doug, with that, you want to go into that? Yep.
So I grew up in Wisconsin, so I got a loud, nasally Wisconsin voice. So sorry about that, but hopefully you can hear it in the back. If you can't, raise your hand. We will make this interactive and do Q&A and stuff as we get going. I do want to cover a couple topics here. What I'm going to go through first is a couple of use cases. We're going to start with Chapman, of course, and then we're going to go through a Dartmouth University use case as well as a Kaiser Permanente use case for supercompute clusters that have been invoked by our team and built, and they're different than what we did at Chapman, and that's why we want to cover them a little bit. As I go through the use cases, I want to get into the technical aspects of what we're doing and why we're doing it, and what we call the stack, or getting up the stack, or this whole concept of bolting these Legos together to build this supercompute. It's fairly simple, I think, from a God's eye view, but as you drill in, the devil's in the details. And we all know that from our regular computers and day to day. So we'll get into that a little bit, talk about the stack, how it comes about, how our team operates, and then really we can go anywhere we want from there. If y'all want to talk what AI looks like, whatever your minds go, we can do that. But Josh hit on something real quick, and he said, he mentioned, quote, "I don't care what leadership said." What he meant by that was leadership at our company, right? We had some interesting challenges internally getting time for our appropriate teams to build this. And when I look back at my career, I started at a little computer company out of Texas called Compaq Computers, which was acquired by Hewlett Packard. When I left Hewlett Packard, we had 320,000 employees. You can imagine the bureaucracy involved with that. And I said, nah, thanks. Went to Cisco Systems, and I spent 10 years there, and we had about 60,000 when I started. When I left, they were pretty close to about 200,000. Yeah, that wasn't fun either. So does anybody know who this guy is? Raise your hands. Anybody know this from Hitchhiker's Guide to the Galaxy? The Vogons, right? I abhor bureaucracy, and these guys personify bureaucracy. The reason why I'm bringing the bureaucracy into this is when we began with this use case and really got into the cluster itself, we were partnered with NetApp. NetApp was going to be our storage. We're going to see what that looks like from a stack standpoint, where they fit in there. But we just couldn't make it work. From the gear that was sent / ordained to be in this cluster, to getting support for various things from the teams involved. It's not NetApp's fault, but it's just a level of bureaucracy that we sort of bang our heads on. And I don't play that. So we shifted gears and we went to Dell. And what Dell was able to give us the second time around, we had a similar thing with them the first time, but they gave us a full Eshcelon with 100% software features turned on. So, and when I say us, I mean, of course, Chapman and in the data center. And so when we did our site survey and we rolled into the data center on campus and we saw these cardboard boxes with the NVIDIA servers, we were kind of sweating what the HVAC footprint was going to look like. So we had to put all of this stuff together and really stress test it. But you can't stress test it as a supercompute cluster until you build it. And so it's sort of that chicken and egg situation. But Dell worked with us to give us some estimates on the power, and we were able to verify that, yeah, this will probably work. And of course, they turned on the software for us. And as we progress through this cluster, where we stand today, I'm going to cut to kind of the end state here, is we're still working with Dell support on one little thing yet. And once that's done, then we're able to complete the cycle. I'll get into some of those details here a little bit, but I just want everyone to understand and appreciate the level of, I'll say bureaucracy, but just the minutia that's involved in getting disparate teams of folks to work together. It sounds pretty straightforward, and it has been throughout my career, but when you look at where we're at in the modern age, it's wild. It just boggles my mind of how difficult it is to get folks to work together.
And we're seeing this,
crazy.
I would say that we're seeing this real time, not only at the university level, but in enterprise, where getting disparate teams to work and collaborate together. These clusters are not built like a traditional compute cluster. The use cases and the different things, and Doug's going to go into this a little bit today, but they're built differently. And if you operate and manage these clusters like a traditional compute cluster, you're going to fail. And we're seeing big enterprise organizations go in with the mindset of, hey, our compute team is going to build the cluster like they normally do a cluster. And what you're seeing is fast forward 9, 10 months when you're actually trying to start putting models onto the cluster, you're seeing failures because it's not managed the right way. It's not built the right way. And if it's done the wrong way, you put yourself in a corner. And we're seeing that real time with a lot of customers nationally that are struggling to try to get their head around building out these supercomputer clusters.
Yeah, absolutely. If we go back in time to 99, 2000 era, kind of remember the Y2K fiasco, right? What the big compute transformation that really hit the industry then, other than the internet was this thing, but really it was a hypervisor, this notion of bringing a hypervisor in and bringing about disparate workloads under a same operating system umbrella. This concept was widely lauded by IT professionals as that looks great for test and dev, but I'm never putting that in production. Look where the world is today, right? I don't know how many times I heard that. So then 10 years later, we had this concept or this notion of hyper-convergence. I'm going to do things like fiber channel and put it on top of Ethernet, and I'm going to run this crazy stacks and crazy stuff where we have to bring in storage people, and we have to bring them with our networking people, and they have to talk in the same room at the same time, and it's horrible, right? And these are things that our team has dealt with our entire career. So when we start looking at this modern stuff where it's even crazier what you have to deal with, who cares? It's no big deal now at this point. Real quick on the technology stack, I have just some crazy architecture diagrams, probably can't even see them in the back. Doesn't matter, it's standard fare Kubernetes is what we did with the Chapman build. We have compute nodes from NVIDIA. These are the heartbeat, if you will, of the supercompute cluster. These are 4 DGX2 systems that NVIDIA donated for this project. They come with 8 GPUs. They actually operate in a dual core mode, so it's 16 GPUs per box. So when we put these together in a meshed fabric, which we'll talk about in a little bit, we're actually running 64 GPUs on this cluster. So if you think about your old school linear algebra programs, you now have a 64 matrix of GPUs to bring about.
H100s, A100s?
These are DGX2s for this project here.
The GPUs themselves.
They are the A100s. Yes. A little older, part of the donation. Yeah. Dell, we talked about a little bit in the storage side. It's Eshcelon. I believe it's 3 nodes. It's a beautiful box. It screams. It really came together and brought this project to where it is, almost completion here. And then our team really built it on top of an InfiniBand fabric for the GPU side of it and Ethernet for the front end public network side. We then load Kubernetes on, which is an awesome tool, as we've probably heard about in the news and through our lives. And it's great for this concept of DevOps called when you put together a service mesh, or if you put together your instantiations of some form of service that you're going to build out. Containers, that type of stuff. It really sucks for doing data science work. So let's back up a little bit and talk about GPUs and why GPUs are the buzz right now. What's going on in Taiwan and Phoenix and all these massive plants going all over the world right now is as much money as we can dump into these plants is where NVIDIA is obviously going to make more money. So when we think about serial compute and the concept of almost a rope or a cable that you're going from point A to point B, that's what compute has been up until recently in the data science realm. And so you're serializing your workload. You can chop up that workload into hunks, and they can process them in these little bite-sized chunks, and then you can bolt them all together again in that original string with the results. When you start talking about GPUs, and you start thinking about your video screen, for example, which is where GPUs came from, you have a matrix. You have your X and Y Cartesian axis. And when these come together, you are unable to really chunk this up properly and think about it almost like a puzzle. And these puzzle pieces have to come together when you start bringing these workloads together. So this challenge has been around for a while. It's certainly not new to anyone who's been in math with linear algebra or any of that nature. But when you start putting this in the compute realm, where you have specifics, things that need to line up correctly, the GPU steps in for the parallelism here. And so when we bolt these together in a single chassis and we have multiple GPUs, we use a technology, or NVIDIA uses it, not me, that makes these GPUs work together. And so they extend that matrix, if you will, out, and that Cartesian axis gets bigger. The other thing you can do is bring multiple chassis together, and so it stretches it even larger. That's where we're at here with the compute. Oh, I'm sorry, with the Chapman project. The challenge is, when you put Kubernetes on this, Kubernetes has this concept of a service mesh, but it doesn't play well in the GPU Cartesian axis and bolting these jobs back together, and this notion of quiescing a job and moving it from one GPU to another GPU and bringing the memory with it. So we have a shim software product called Run AI that really makes Kubernetes work in the data science realm. Now, Run AI does a lot of things. It's awesome software that does several things. But the key role in the projects that we work on in this realm is that concept of almost bringing vMotion into a GPU and bringing a data science workload that we can now move around the cluster wherever we want and bring the memory with it so that it can accomplish the job. It's a small piece, but yet it's a critical piece. Now, if you're not running a Kubernetes Run AI type thing with AI, our team generally recommends something like a Slurm instance as well that really is built for AI. The difference is Kubernetes containerization runs at the root level and Slurm runs at the user space. So that's the key difference really between those technologies.
And Doug, one of the things around Run AI, Israel-based organization, they've been on our radar as part of Trace 3. We have an innovation team that focuses in on like up-and-coming organizations that the VCs are backing. Run AI has been top of that, and now more recently, over the last year and a half, NVIDIA has actually baked Run AI into their DGXs as an offering as you kind of work through that. So we're seeing that real time, and a technology that allows you to almost manage and monitor GPUs as you give workloads out to data science teams.
Yeah, I mean, so when I come into a project where we're looking at optimization, so we have an existing cluster running Kubernetes, doing data science, and the data scientists are just scratching their hair going, how come this isn't just giving me what I thought? Mathematically, this should be working, but I'm not getting the optimization I want out of my teams. We put in Run AI, and it changes the optimization from 83% to, say, 99%, almost overnight. In fact, that's their sweet spot, is an existing cluster that's struggling for that optimization. Sounds like a sales pitch. I'm just super passionate about the tool because it just kicks ass at what it does and what we're doing out there, which is, you know, we want jobs that are maximizing our GPUs and compute. We want 99% utilization. That's what we want. That's why we have this investment. So we just want to maximize our hardware. Now, I'm going to talk about a stack a little bit, shift gears. We're going to get back to the use cases kind of at the end here. A couple more use cases. So in the old days, and we talked about a stack, you had compute and you had storage and you had networking, and that really was your computer. And okay, we're going to Okay, I'm put on my Cisco hat, and we're going to talk about chaining multiple computers together, and they're going to do things in the data center, and we're going to change how we do networking, and we're going to have switches that talk to each other, eliminate spanning tree, and things of that nature. And then we start talking convergence and hypervisors and things of that, and we're going to bring workloads in. The stacks now are a little different. And so I start at the bottom with any education on the stack, dealing with storage. It's a foundation of what we're dealing with. Whether it's petabytes we're dealing with, whether it's latency, whatever we're ultimately dealing with in a challenge of an HPC, HPA environment, storage is the foundation. We're bringing data into the system, we're coming up with some sort of result, and we're shipping it out of the system somewhere. That's all part of storage. Could be object store, NFS, any of this technology that we have heard from yesteryear. There's a lot of options there. That's where we start assessing and analyzing and really communicating with clients. When we go up the stack in a compute, had a conversation today. Well, what's a better processor? AMD, blah, 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 or an Intel, blah, blah, blah. I don't care. We figured out compute 20 years ago. It's just compute. Who cares? You don't have enough? Put another one on there. I liken it to when grandma says, I want to buy a new laptop. Which one should I get? Who cares? What's your budget? Spend your budget and move on. They're figured out. We can figure it out in software now and solve the challenges. And so I really put a lot less stock at this layer now, but some people do. I just try to break the mold a little bit and get up the stack.
Well, you're finding a lot of the OEMs, Dell, HP, Cisco, that's where their focused area is currently right now. And we're trying to push them away from that. They're meeting with my team, Doug, and our folks to try to figure out how they can harness that, because ideally, all Dell wants to do is sell more compute, right? So, and that's where they make a lot of their dollars and their money. But actually, when we look at a lot of the OEMs from a compute standpoint, Dell is really up their game when it comes to that. But you're seeing HP have a flavor, Dell have a flavor, Cisco, Supermicro, all of these OEMs that are the traditional OEMs start to play in that a little bit. But to Doug's point, we don't care, right?
And they all spell AI the same way, all these manufacturers. They all spell it Gen AI or LLMs. I don't get it, but whatever. It's all good. Moving up the stack here, operating system. Our team prefers Ubuntu. It's awesome. It reminds me of, kicking old school Gen 2 type Linux kernels I used to build just for fun. We really like it a lot. It gives us what we need to get the job accomplished. Often there's requirements in shops to deal with Red Hat. Not a problem. I'm a Red Hat guy too, an old RHCE from yesteryear. The issue with Red Hat, though, is their Kubernetes version is OpenShift, right? And so you're dealing with now a different kernel than the stock Red Hat kernel. So there's actually 3 operating systems that kind of play in that space, whether you're doing OpenShift, Red Hat, or Ubuntu. Excuse me. On top of the operating system, our team has a suite of tools we like to use for cluster admin. One of those tools is Clush. It's kind of a collection of Python scripts. Our motto is just clush it. It's pretty cool. If you're Linux admins at all and you want to say do a date or a dir or something, you clush it and it'll give you all the nodes. So if we've got a 20,000 node cluster, it'll report it, aggregate it, roll it up, and you can see all 19,999 nodes that came back, and then one of them that didn't. It's a summary view. It just kicks butt at what it does. I love it. So we do a lot of those types of things, your SSH, your tunnels, any VPNs, that kind of stuff. Adjacent to that, we have GPUs. So I'm calling it GPU, you can call it the hardware, but in reality, it's an NVIDIA, it's a software stack. So it's really the CUDA toolkit. And the reason why it's so important is CUDA is ruling the world right now in that space. You can have your allegiances to a different GPU vendor, but that CUDA toolkit is really what drives the data science world right now. Now, I have a particular allegiance here, hence the purple part, but this storage here has a hook into CUDA. And so one of our partners that we work with significantly in the storage space for extremely high performant compute is a company called Weka. And they are a software-based storage platform that only works on NVMe and SSDs. That's it. They won't support anything else because of the speed. Well, they have a GPU bypass situation. So you can bypass the operating system and have the GPU talk directly to the storage itself and act. The GPUs can actually do your transformations, your LLMs. You can do that stuff on the data at rest on the storage platform. It's insane. It's crazy. That is unbelievably fast. However, when we start talking something like this, you know, I'm putting on my sales hat real quick, speed costs money. How fast do you want to go? So there's trade-offs. It's that old triangle of all the things that we have in compute and technology, and of course there's always a budget you have to assign to it. To wrap up the stack orchestration, we talked about that briefly. This could be a K8s, Kubernetes, we call it K8s layer, or Slurm, really. Our team operates with both. There's pluses and minuses on either. And then on top of that is our data science stack. And you know, we say it from day one, this is where we want to get. This is what we want to do as a team, is get up the stack. All this other stuff, we got to figure it out. Let's bolt it on, let's roll. Chapman's no exception, right? Now, Chapman's situation on what we're building, other than the time taking a little longer, is that data science stack involves a couple of interesting components. Again, some donation software we're able to secure from a company called Deci. And so we can do both generative AI with some LLM software, what they have, and they could do traditional data science modeling with the software as well. Really, we have not sat down and banged out a couple of use cases yet for that particular side of the upper end of the stack. We're waiting to get this going, get the admins going, kind of kick the keys over, take a car out for a couple laps and see how fast it is type stuff. It's coming, it's right around the corner. I'm not worried about it at all. But what I want to do now is delve into the granularity of each of these layers. I think. So yeah, you're not going to be able to see that. I'm going to zoom in on this here. So I'm going to start the bottom half and sort of zoom that up here. So this is that Weka thing I talked about earlier. It doesn't have to be Weka. I'm personally partial to it. We can put NetApp, in this case, we can put Dell storage on there. Pretty much any storage does the trick for what you're doing.
But I think the key, Doug, is you need storage.
Yeah, you have to have storage. It's the foundation, right?
Yeah.
Now, the other part of that is we're dealing with HPC, and you've also heard me say HPA. We're changing the nomenclature again. It's no longer high-performance compute. It's high-performance architecture. We care about the overall architecture. That's why I kind of started with the stack. Now, we're talking high performance, which generally means extremely low latency, extremely performant X, whatever that component is. That's why I have an allegiance here, is the performant nature of it. Excuse me. As we go up here and we start looking at the infrastructure, that gray box really, I've got cloud or I've got on-prem. The team I work with predominantly works on-prem because of the nature of data gravity and the nature of experimentation that occurs with the projects that we get brought into. However, we can also go cloud. It's no problem. It's the same language. It's just slightly different somewhere else. Or often we'll do a hybrid between on-prem for, say, inferencing, and then production modeling we'll throw in the cloud, or vice versa. A lot of clients will do vice versa. You want to talk on that a little?
Well, just, I mean, I think one thing that we're seeing real time is GPU as a service. So what ended up happening is these Bitcoin farmers, they're the ones that hogged all the GPUs. And so more recently, when you're not able to get GPUs for, I think lead times were what, 52 weeks? Or something like that, where organizations are trying to build out these HPC, HPA clusters. They're not able to get the GPUs, so now they're pointed toward these Bitcoin farmers that have access to GPUs. And these organizations, the Bitcoin farmers, are turning into GPU as a service organizations that are offering up GPUs as you kind of look at it, and now that becomes a streamline of how they make money and how they operate. So we're seeing that real time. There's several organizations, 5, 6, that are top of mind that are kind of focused in that GPU as a service because of the demand and obviously the big trend toward Gen AI and LLMs. But the demand for GPUs is becoming relevant, and so that's becoming another option.
It's changing the world.
Yeah.
It's, when you look at the plants they built in Taiwan and how they're moving that here I live in Phoenix, and what's going on in Phoenix right now is absolutely boggling my mind from the amount of construction and building they're doing around there. There's a lot of thermal reasons for that and other issues with power and stuff that makes sense. But I liken it to the overall data conversation when you start talking about data transformation or organizational transformation to begin with in a digital sense. It's never about the primary use of your data or whatever you're doing. It's always about the secondary and the tertiary and so on, uses of the data and the results you get from it that are going to be your surprise money makers. And it's really about organizational discipline to understand and recognize that in order to profit from it. And that's what the Bitcoin guys are doing now. And again, I talked enough about the CPU, GPU. Infrastructure's figured out. Let's roll. If it's that bad, put it in the cloud and we'll move on. It doesn't matter. It's straightforward. I waste 0 time sitting there doing megahertz conversions or gigahertz conversions or RAM. If you're out, put more in. This is the least part of the equation we want to work on.
Well, you're seeing I think you're seeing a big trend of, because of the cost of cloud, bringing those models back on-prem and training it on-prem and then bursting it up to the cloud is a big thing just because of cost. And how do you manage that cost? Sorry, go ahead, Doug.
Yeah,
I keep chiming in here.
No, it's good. I like it. I'm sweating. So I threw a yellow box in here. It's a little different than the outline one. Really, this is your organizational software. Think of it as your security organization saying, we must do X on every system we have. Again, the bureaucracy, right? I loathe bureaucracy. Our use case here at the end, we're going to talk about a little bit. A healthcare organization, KP, you guys are probably familiar with Kaiser Permanente a little bit. They have an organizational structure that mandates security on every system. Now, an HPC cluster of this nature is different in every aspect, but they don't care, they're putting it on. So we went through about 6 months of rigorous testing of 24 different packages that they mandated were installed on each of their nodes of their supercompute cluster we built. We had to work with performance first and foremost, but outside of that, we had to make sure things like Kubernetes actually worked. We had a hell of a time getting Kubernetes to even work on data forwarding to Docker containers with some of the software decisions that they had made and mandated. And we had to get exceptions and play the political game, which I love so much, and it was just a challenge. And I'm not picking on KP for this. I'm picking on organizational discipline and organizational bureaucracy that's out there. We've all seen it. We've all have a part of it. Number one is the government, right? Can you imagine building one of these for the government? That's the kind of stuff that we can help assuage with the conversations and whatnot and discuss. Sometimes it works, sometimes it doesn't. But these are conversations that we have every day. Getting up here again, I talked CUDA software a little bit, some of our cluster management software. In this example, I'm kind of talking about Slurm a little bit. There's not a hell of a lot of difference with Kubernetes. It's very similar structure. I think the control plane with Kubernetes is broken out a little bit different. Again, you're doing your service mesh type environment with Kubernetes versus Slurm, it's really user space. So a user job can be moved around the system. Not too much difference there. And by the way, I forgot to mention in the beginning, we will have these slides available afterwards. I think Michael, he was like, hey man, where are your slides like 6 months ago? I'm like, yeah, we just talk and we'll see what we come up with. I got whiteboards out, we can do all kinds of stuff. So I want to see what we do as a room and we'll go from there and I'll bolt it all up and package it out at the end. This here diagram really breaks down the cluster for anyone that's new to compute in a distributed fashion into the control plane and then the worker plane or the actual communication plane, the data plane, if you will. The control plane in the gateway, action the cluster itself. It's the scheduler, jobs are submitted to it, it doles it out, it runs the jobs, it tells the worker nodes what they're gonna be doing, and then the workers go do it, and then they aggregate it and roll it back up to the control plane. The control plane manages all that. We never have one system. We always have 3 or 5 or something of that nature in the Kubernetes world. Slurm, we can get away with 2. We can go down there, but we typically want 3 or 4 as well. I have seen customers put these in the cloud because they don't care. They're control plane nodes. We'll put our money in the worker nodes on-prem. I've seen it the other way, and we've seen both on either or. It doesn't matter what you do. We architect for all of it. Excuse me. The worker nodes can scale then in basically whatever your limit of your budget is. Now, I had mentioned compute doesn't matter before. An example, you buy 10 systems that have X processor with Y memory, and then, oh my goodness, we're gonna add more systems into the mix. Why don't we create a new class of systems then in the cluster and actually just buy new systems instead of trying to upgrade? We'll let those do whatever jobs we have. We can segregate our jobs accordingly, have like a higher speed one and a class A, class B. We can do things like that. We can do GPUs. Had a conversation today. Customer wanted 4 GPUs in some systems and 8 GPUs in others. Fine, we can do that. But you know something else we can do? Just blast out whatever your budget is, and we can use software like, say, Run AI to partition those things for us so that our teams are over-quoted or under-quoted, and we can be very dynamic in our data science workloads. Because again, I don't care what hardware and how many transistors you're buying, let's maximize them. Let's get 99% of transistor utilization out of your cluster, and we can do that with software. We can't do that by proactively planning out gigahertz speeds and feeds of systems. So up the stack at the top is our ML Ops. I got it here for ML Ops. That's one of the use cases we can talk about. This is your framework, right? Are we running TensorFlow? Are we running, what are our notebooks doing? These are things that I envision at Chapman. There's a couple use cases have been bandied about, but certainly from an education standpoint, this is going to be where we have close interaction with our faculty, we have curriculum, we have development, and we really get to see students getting hands-on at that layer. That's what we want. Students may be interested in some of this stuff. I don't know. That's cool. Some of it's okay. But it's old school admin. You want crusty guys like me doing this stuff, and then you get the kids doing the new stuff and getting to learn the cool stuff, right? But knowing the system of all, from top to bottom, that's key as well.
Yeah, we're seeing a very big need on the enterprise space. I was mentioning manageability of these clusters, operationalizing of these clusters, the need of having folks that understand all the way up the stack and can talk data science to the data science team, because that's a need too as well. And so you're really seeing firsthand organizations that the need is there for somebody to manage this environment because of all the components that are in play here.
Give you guys an example. One of the things I have up here, just by way of example, in the green box at the top, I have pipelines in there, okay? What that really refers to is data engineering pipelines, right? I guess we could kind of consider ourselves data engineers on our team. I mean, 90% of what we do every day is data engineering. We're taking data from here, and we're doing something to it, and we're putting it over here. And that's what data engineering is. How do we automate that? How do we go through this? Well, these are things students need to learn as well, and that's also part of any operational framework for compute clusters, supercomputer or other. It's about getting your data and moving it through the system and setting it up, the rules and the orchestration around that. That's just one example. There's a whole science behind data engineering that is set through curriculum. If you start looking at higher ed, and I'm sure you have some as well at Chapman around just pipeline development and data engineering overall. It's such a need out there that it outweighs data scientists right now for hiring. Everybody's looking for data engineers because nobody knows how to do this stuff. It's crazy. And you start thinking about Python and these other tools, some of them identified there, some of them not. But that landscape of tooling changes so rapidly on a day-to-day basis, it doesn't make sense to say, I'm going to pick this tool. Understand the framework around the tooling and understand what you're getting accomplished, and then you can start diving into the tools from there. That's kind of what I wanted to just harp on there for a second. All right, let's hit some use cases. Somehow, I don't know why that's twice. All right, so I talked KP a little bit. We did a very similar stack. We did a couple things, have a couple different classes of systems. We're doing some Intel Optane systems. They did some Hewlett Packard systems. We were part of the NVIDIA systems that went into the cluster, but we also managed the entire cluster. So they had 3 classes of systems in here. We ran a vanilla or stock or straight open source version of Kubernetes. The stack is very similar, except maybe this yellow area, there's a bit more there, as previously mentioned. Logically speaking, it's just a standard compute diagram. This is nothing fancy. If you can't see in the back, it just calls out your storage and it calls out your compute areas. The glue that brings all of this together, of course, is some networking. Now, I haven't talked about that on the stack at all, but that's our interchange between layers. And when we talk, again, HPA, high performant architecture, we want extremely low latency, very high performance interconnects. So this can easily be 800 gig Ethernet. This could be 400 gig InfiniBand, Rocky. These types of technologies are what we deal with in this extremely high performant, low latency world that we have to live in. If it's my budget and my money in building one of these from scratch, I'm putting my money in that first before I look at GPUs, certainly before I look at CPUs, and then storage as well. But it's all about the latency of the interconnection, how these systems talk to each other. If you think about taking a workload for a user, a data science experiment in a notebook, and moving it from a GPU to another GPU inside the system, and what that's doing to what we used to know as a PCIe bus, but in reality, the caching and all the layers and the interconnectivity in that box, now transpose that outside the chassis to another chassis in this compute node. These 2 areas are extremely important. And I'm pointing out NVIDIA for the InfiniBand because they bought a company called Mellanox. They own them now, and they pretty much rule the InfiniBand space. So when we look at this, we're looking at InfiniBand, high-speed Ethernet, or Rocky, really, is what's going on in this space. In Chapman's case, we're doing a combination of both. We're doing InfiniBand on what I call the back end, or this is sort of this network here in the yellow. This is our GPU to GPU communication, inner chassis communication. And then we're doing Cisco and, well, traditional networking. I don't mean to promote Cisco here at Chapman, but traditional networking Ethernet on the front end part of that cluster. So data will come in, access will come in via Ethernet, and then on the back end jobs will be running InfiniBand. In this example with KP, we use NetApp storage, traditional NFS. Again, extremely highly performant storage. NFS shares were mounted on InfiniBand, so we were at 400 gig for the individual nodes. We had 25 plus 10, I lost count, but somewhere around 40 nodes in this cluster that connected to their NFS stores, and we had a beefy enough storage system that it was not saturated at any point on the controllers themselves, so that they were able to serve the data appropriately for their data scientists and their use cases they went through. They ended up splitting the cluster out and they had a little phase they went through where they wanted to play with OpenShift a little bit. So they took some of the Optane systems out, built another cluster of OpenShift. Last I heard, they put them back in and put them back into this existing Kubernetes cluster. OpenShift has sort of some nuances to it. Anything Red Hat and what they've done to the open source world does. I'm happy to have a beer with anyone if we want to discuss after. I don't want to get too opinionated. But that's a lot of our team. We're opinionated because we've been in the trenches and we've bloodied our knuckles and we know what it's like over the years. So we do have opinions on what to do. But in the case of OpenShift, they run a different kernel with their Red Hat. And it plays havoc when you start doing things like treating it like a regular computer and you put software on it. It's not made to do that. It's a different type of a kernel. So, do you have anything you want to add on the use case for
Nope.
KP? One other use case I want to talk about.
The biggest thing that we talk about all this the entire time is like literally Doug and our team went into Fort Knox and got in somehow, and were able to build a cluster inside of Fort Knox, which was almost impossible. Kaiser has a team that's just dedicated to security requirements and the challenges around security. And so you have to get by them before you can actually go do anything within the cluster. And so we had a long time of going back and forth within that team because they wanted to manage this cluster like a traditional compute cluster. And we were educating them almost on the fly as they kind of work through managing and operating this cluster the way that it needs to in order to feed the data science teams the right way.
Okay, so I'm going to cover one more use case, talk through this just a little bit, and then we're almost at 8, and then we can switch to interactive Q&A, whatever you guys want to throw at us. Happy to do it. So in this particular cluster situation, my team was involved with coming into a client who had purchased this through a different integrator. It was built in a certain way. Slurm had some nuances to it, and I was able to communicate to the team at the customer effectively that we needed to change a couple things, basically. So we went in and sort of tore it down and rebuilt it, if you will, remotely. If you look at this diagram, it's fairly similar. The difference is instead of NFS, we're doing object store for this particular build out. They're doing some genomic research at the Dartmouth Health for this cluster. What they actually had, as we started getting into it and peeling the onion a little bit, is that, and then we see this all the time too, is they have a operating cluster in the cloud of 5,000 node systems running in AWS, fairly typical, and they wanted to have, because of data gravity concerns, talk about that in a second, they wanted to have a little snapshot on-prem that they could keep some data private. Now, data gravity is a concern in every single project that we come into, and that's typically why we started storage. Because data gravity dictates what you're going to do with your system. Whether you're Tesla, or whether you're a healthcare, or whether you're a credit card provider, or anything else in the spectrum, data is your king of your business, whether you acknowledge that or not. And so when you put this together and think about it, a lot of companies trust their data out in the cloud, and a lot of companies don't see it that way, and they want it on-prem. We can obviously shift gears and be nimble in any direction that we want, but we see a lot of research institutions, higher ed, a lot of schools that are teaching their students. We see a lot of this data being on-prem, and a lot of these clusters get built 100% on-prem for that reason. You want to comment on any of that, or? Okay. In this example here, we were able to rebuild the Slurm cluster, get things up. There's not a lot of extra software on top when you're running Slurm. It's really about user access, and Slurm operates on this notion of partitions. So you build out your classes of systems, if you will, with partitions, and serve them up that way. One of the interesting things that came out of this is I started thinking with our team, really, well, why do we have either or, Kubernetes or Slurm? Why don't we throw both on the same cluster and see what happens? And so we've been playing with that a little bit in our lab. At some point, I think it actually is pretty cool. But remember, the key difference with Slurm is that it's a user space operating, or container is a better way to put it. It's a user space container, whereas Kubernetes is in root. So It's interesting that there are a lot of code out there to run Slurm in crates, but I didn't want to do that. I want to run them in parallel and have separate, unique jobs going. And we're pretty close to actually doing that. So it's pretty interesting so customers can actually see and experience both, because they are wildly different on how you do your jobs from a data science standpoint. As far as Slurm goes with the stack, all the stuff at the top, the operation of data science, whether you're dealing with notebooks or experimentation or bringing data in and pipelining, it's all exactly the same. I do have a last slide to kind of show you on that. Let me toggle over here. So this is data science from our standpoint. And this is that layer above the green that I didn't show yet. This is data science workflow. How is data science being done in a distributed compute HPC environment? And this is really this entire notion of persistent data volumes, of having jobs get the process, the inferencing, the training, but then operating them in this notion of pods in a Kubernetes world, and having them run through this container registry, which really dictates where my code is. So now what are we dealing with data scientists? We're dealing with coders, we're dealing with data engineers, we're dealing with pipelines, we're dealing with release and code, security. We have all aspects that are really affecting what's going on in our data science workloads. And when we start kind of looking, when we have these conversations with customers, there's this notion of domain 10, and that's really what we're dealing with here. And there's no way to really have a zoomed in version of this. But we're dealing with platform engineering and security and finance and budget, and we're dealing with all these elements of an organization that come together in the realm and the notion of data science. And really, what is that task at hand that's occurring? Conversation we have with a customer today in the R&D department. Very typically, we talk to folks in the R&D department because it's the lifeblood of that organization to reinvent itself, and they're experimenting with the data they have on hand already. So that's one thing I want to encourage everyone to do, is look at your data and experiment. Set up that citizen data science team. Set up these centers of excellence and expose your data to your teams to allow innovative thinking to occur in your organization. So with that, that's all I've got. We can go Q&A, or you got anything?
No, I mean, I think just what Doug was saying here is it's very, it's kind of a unique dynamic, because within our organization, again, if you go back to the traditional cluster around compute, storage, network, our sellers and even our customers, they were going down a path of like, this isn't working, make it work. And we're kind of down this path of like, until you actually see where the gaps are, you have to be able to break it, iterate on top of it, continue to find out where those gaps are. And you have to be okay with doing that inside your organization. And I think that's where a lot of struggles happen. And one of the other things is a lot of customers we're talking to, depends on where you talk to, because we could be just talking here and they care about this, or we could be just talking here and they're looking at it holistically, or just even the data science teams who have their opinion of how things should operate and how they work it from that aspect. But what I think is super cool is, you mentioned research and development. Well, HPC was predominantly for research and development, right? That's where you, in universities, hey, well, we need, the only people that have HPC is research and development. What you're actually seeing now is
mainstream.
Mainstream. It's moving into the enterprise. It's driven that way. And you're going to see these iterations of technologies kind of start bubbling up and really helping out. I mean, I noticed that IBM is a sponsor for you guys. IBM is doing some great things with Watson and Watson Studios and what they come with, their IBM Cloud Pak, right? And there's all these different technologies that you can fit together, but we go down a mindset of leverage what you have, configure things to make it work together, because that's kind of the way that things are moving toward, not so much separations and silos, and only build net new when you need to build net new. And that's the conversation we're having with a lot of customers, because again, you can buy a piece of software and then now you're beholden to that piece of software for the next 3 years, and you're trying to figure out how it works.
Or worse, you can hire us to write a piece of software for you. I mean, we don't want to do that either. I want my team to fail. We love breaking stuff. Let's break it. Oh, this sucks. Change your DNS. Oh, you know what? It's a leaner, meaner organization that comes out of it. Yeah. It's better for you. It's better for us. It's a better budget. And now we have a relationship as we work together as a team going through this. Yep. So anyway, thanks for your time, everyone. Oh, let's Q&A. I'm sorry. So thank you.
Thank you, Doug. I'd like you to talk about the actual use case of the one at Chapman, and I believe that the first in the queue is this digital twin concept from the Department of Public Works.
Sure.
So yeah, talk about that.
The digital twin use case at Chapman from the, and I'm sorry, it's the Department of
Public Works. Yeah.
Public Works. Okay. All right. Is Costas here?
No, I don't think so.
Okay. Rats. No, I'm just kidding. So with the Chapman project, I have been sort of arm wrestling to get use cases like we do with every customer. It's not that big a deal. But Chapman has definitely got a couple of use cases that are pretty cool that we've started thinking about. I like to ideate on these. In the case of the Public Works, is it Department of Public Works, they are modeling, I'm trying to think of the industry it came from. I used to work in it. Basically in the cloud, they're modeling visualizations of infrastructure like power grid systems, the waterworks, roads, traffic lights. And they're building this concept called the digital twin, which is a mirror of the physical nature of our existence and putting it in a mathematical model. In this example, they're doing this in the cloud today. What we want to do is bring aspects of that, again, these little chunks we want to bring down. When I say little, it's relative, they're massive. And we're going to use the GPU power of the supercompute during idle times, in the evenings, maybe when students are offline, when jobs are quiesced. We'll have a run AI kind of tell us when to do certain things and do it for us, which is cool. And use that power on-prem to manipulate and build the graphic part of this digital twin. And what that does is take some of that workload out of the cloud, where the cloud, whether you believe it or not, your CFO thinks it's very expensive. And so we're going to bring it on-prem, crunch it, and then we're going to throw it back out. Has some very unique challenges. First of all, the data sets we're talking about are massive in size. So we're talking about how to bring these into this existing supercompute cluster at this layer and have a fat pipe, so to speak, to bring this data in so that we aren't waiting on the data to come through for this job before we start crunching it. And then the job gets done, and then we have to move that data back out. We don't have contention and all the things that come into that. Now, I've only begun scratching the surface of this particular use case. We haven't fully ideated it yet, and just because of the nature of building this cluster out. One of the things that's super cool in this industry is it's oil and gas related. It's basically, if you think about when you drive around, you see a light pole, there's a number on it, right? Serial number. Well, in the old days, like 90s, somebody digitized that. They had a mouse and the green board architecture screens, and they would actually put their crosshair on and say, no, it's 2 more inches this way, and they had a serial number, and all of this was mapped that way. This is using inferencing to detect from things like Google Maps or people's pictures of the area and whatnot to actually get a granularity that's significantly more accurate than a human being putting in that data. All of these things are coalescing into massive data sets with massive pipes. It's something that is pretty exciting, and I'm looking forward to working on it, but I just scratched the surface right now on it. So I can't really speak too much more than that.
Really, the point of my question was to kind of ideate about what are the possibilities for Orange County. So that was like one example.
Okay.
Not that we've actually accomplished anything yet, because we haven't, really booted the thing up. But I want people in this room to kind of give us ideas, and maybe you could
From a community standpoint.
seed that with some of the ideas that have already been tossed your way.
Okay.
So that we can get the conversation rolling about what we can do with this resource.
So from a community standpoint, Michael's asking for ideation in this room to come together with things that you may have. This gets back a little bit to my citizen data science, but think about things that a supercompute cluster could do data processing wise in your own realm or walk of life or whatnot that is akin to something like the digital twin or any of the other examples that we kind of went through. We're happy to talk through a few different examples also that we haven't shared yet, but would like to just ideate as a team, I guess. Is that fair? Okay. Oh, that's a great question. Okay, so the question is, if somebody, as a solution integrator, if somebody brings a project to us, what do we charge for that? And my answer to that is very simple. What's your budget? And then the second question is, just kidding. The second question that you had was, who owns it after it's complete? Which is a great question we haven't even talked about yet.
I can start on the first one if you want.
Hammer.
So one of the things we saw that as a really a need, right? There's a couple things that we have seen we're running into challenges. One, nobody can prioritize use cases, right? That's the first thing. And then two, prioritizing data sources to be able to go drive those use cases. We started going down a path of, because of all these conversations, what we end up doing is whiteboarding, and nothing actually ends up getting done because of all of the politics and all the challenges, right? So typically what we do is we start out, we call it a 10Q assessment. Are you ready for AI? Or can you work through that? Part of that is talking to, we call data science the business owner, but talking to the business shareholders, tying it in back into IT, and then formalizing some sort of level of effort after that 10Q to say, all right, here's 2 or 3 use cases we're going to prioritize. Here's a framework of things that we need to go accomplish. Part of that 10Q assessment, are you more on-prem? Are you in the cloud? How do we go work through that? That allows us, as that 10Q assessment, that allows us to go formalize what any sort of level of effort is for the business. We think this is such a key piece because I think what ends up happening is, in a couple of these examples that Doug was saying, we started building out the cluster without a use case. That was cause for disaster because what ends up happening is everybody comes to the front of the line and everybody's trying to feed off of, at the buffet, and nobody has any sort of prioritization, and everybody's problem is top priority, right? And so we feel that has been very key for us to be able to get to whatever that cost dollar is. Now, again, going back to the leverage, configure, build, the reason that we do that is because we want to leverage tech that's already existing. And if you saw the Kaiser example, they already own NetApp, they already were Cisco, they already had HP, they already had Intel Optane. They were going to make an investment in GPUs, so we knew that was coming to the table. Red Hat was obviously key to that, but we had to assess kind of what that looked like and then frame up the dollars that made sense. But what we're seeing firsthand within chief data officers, data science teams and whatnot is, yeah, Josh, you can provide us with that first initial phase dollars, but my CFO is asking me for the next year. What does our investment look like around AI, around Gen AI? How does that look like from that aspect? And one thing we're seeing a big push in Gen AI is really around productivity inside the workplace. Leveraging Gen AI to go do my job better, right? Can I build a chatbot to go find a document? What ended up happening on the Kaiser use case was it was kind of during the height of COVID. And one of the challenges that they were having was, and I don't know if you remember this, is you would pull in to the COVID testing center, and there was no Wi-Fi in these parking lots. And so they would take a picture with an iPad of your license plate. That would then get uploaded into a application somewhere, take forever to fill in that application and push it back down. And what was causing it The problem that was causing it was the business case was that the lines were too long. If I showed up for 3 o'clock, I may not get in there until 10 o'clock at night. And so we started leveraging this platform to start feeding data and those models into there so that we can turn it around, see trends, know when to place people, where to go through there. But that was one of the original use cases as we kind of worked through that, right? And so as organizations start to understand some of these business real-time use cases, that's what's happening. We are the official, I don't know if there's any sports fans, but we are the official analytics partner for the Detroit Lions. Which is kind of cool because they won and it was all great. But one of the things that we're working with them is not only around fan experience inside of the stadium and collecting data and putting it into a platform, but we're now working with the city of Detroit around a digital twin that starts bringing data from, we're actually calling out 10 different intersections and making them smart intersections. Cisco's investing some gear to be able to go do that. But from a digital twin perspective, the art of the possible actually comes real time. How do I go to a Taylor Swift concert, and how long does it take me to park, to get into the stadium, and to get to my seat? We now can track that inside of Ford Field because of some of the things that we're able to do. And so when you start talking about real life use cases, those are things that we're driving toward that. But it's hard to put a dollar around exactly what that looks like, and I think that's why we've taken these steps. Not everybody wants to do an assessment, but what we're seeing real time is organizations are investing in this, and whatever path they want to go, and we're seeing a lot of organizations go, hey, we're creating an AI center of excellence. Here are key use cases that we want to go after. How do we get there? And we kind of sit back and go try to drive that level of effort.
And I'll add on that too. The cost, I think, is a dollar thing from a sales standpoint, yes. But there's the business unit internally to your organization that has a cost too. So there's an investment that comes from identifying stakeholders to help us ideate what these use cases will be, not only for what this thing's going to do, but what are you going to do with the results? How is it going to change your organization? These are things that very few folks actually think about as they go through, yeah, we have to have this. I have to have a driver's license scan thing. Okay, what are you going to do with the results? How are you going to evolve your business and grow it, right? Organizations that typically this comes up through R&D, they already have that baked in. So they already know it's good for the business unit.
Well, and I think, Doug, to the point of Chapman, it's so interesting because we're going through this effort. We're building a supercomputer in Orange County, and all of the different opportunities, and we call it the art of the possible, start building up. Now we can talk digital twin. Now we can internships. Now we can go educate our students and tie in other universities to go actually do real-time model building, right? These types of things now start becoming real life and real time. Now you start going out to the community, and we had one, I think, high-level conversation around water management in the city of Orange. How do we embrace that? What are the key things that we need to go do? All of these things start becoming possible because we have a platform that we can go build off of and work through. And what's interesting is as I come to a lot of these sessions and meetings, ideas come out. How do we keep students here, right? What are the trends in housing? If we are going to be, if Orange County is going to be the center of excellence for AI, the challenge is like, how do we keep students here and make it affordable for them to stay here, right? And all these things start coming to fruition as we start working through that, and that becomes all these business challenges that we're trying to solve. And a lot of organizations are doing the exact same thing. We're in meetings on a daily basis with Netflix on how they're trying to charge you more. And again, autonomous vehicles start becoming relevant, all these different use cases that are happening. But I think out of all of this, what's end up happening is everybody wants to give their customers a better experience. How do we go do that? We can leverage data. We can leverage AI. And now, the complexity of a supercomputer, which used to be a very daunting task, can now become something that's real life and bring to the forefront.
And your second question, who owns it? Okay. Are you speaking from the university? Are you speaking from an organization?
Both.
Both? Okay. So we come in, the use cases we showed, typically that organization owns it, right? Now, if you mean inside the team of that organization, so the code that we develop and write and That's the cost of the engagement, right? That's your code now. So when my team operates, we do things standard procedure. We run with Git, and you own the Git repository when you're done. That type of stuff, right? As far as inside your organization, well, that's when you start talking silos and you start dealing with business units. I'm the storage guy, I own the storage. Okay, fiber channel guy, go LA, right? Those types of questions. But from our relationship of Trace 3 and doing an engagement, yeah, you absolutely own it. That's the engagement.
I think it's an interesting ask. Because what started as is like, hey, I'm a data scientist and I have a DGX under my desk and nobody's touching that and I'm not telling anybody that I have this, right? And now what's ended up happening is as you start pulling all these disparate data sources together to formalize outcomes, we're seeing real time really a challenge between IT and security. So the CISOs are collecting all this data. Well, IT supports the data and analytics team, and the data and analytics team runs the platform. Well, if I'm a CISO and I want better insights and I want to run analytics on the data that I have, how do I get that? Well, the data and analytics team won't let me have that, so I got to go build my own, right? Now you're in that, now it becomes even more siloed. We're trying to have more and more jointed kind of conversations based on some of these types of use cases because data's touching everything. How do we go formalize that the best way? It's an interesting conversation because there's people that are taking charge and owning these platforms, and then they're saying, hey, we own the platform. We're not going to let everybody just come on here.
So let's take that same question and let's twist it a little bit, okay? We all love Gen AI. It's the topic du jour. Let's talk Gen AI. So you hire me to write some code for you to do something. I chat GPT that because I'm lazy, and I give it my style sheet so it knows my style, and it accomplishes that task, X, and spits out this code, okay? Do you own that code? Is that my code? Is that my company's code?
No, this is the issue that's why New York Times is suing ChatGPT.
Yes. So this is what we call in the data science community the ethical dilemma, right? And so ethics is not about right or wrong. It's about this no-win scenario, as anyone's gone through the ethics stuff, right? It's a challenge right now. It's a huge challenge, but it's fundamentally different than what we talked about line of business owning it. But when we twist this around now and we start thinking about the ownership of code or task, and then we start assigning responsibility to it, it just adds another dimensionality to it all.
Yeah, I think, going back to your question, the Kaiser scenario was the operations team then became kind of owned the platform, but then the data science team was the one that was driving all the initiatives on the platform. And it became a little bit blurry. And that's, I think, what's ended up happening is now, where DevOps was separate from the infrastructure team and separate from all that is now starting to blend together, and it's becoming challenging from that aspect.
The question was, is this going to be exclusively for Chapman students? And that's not the case. So Chapman students will have priority in a sense because we're hosting the thing and we're providing the power and cooling on a day-to-day basis to keep the thing running, and we're providing the staff to do the sysadmin work once these guys have turned over the keys. There already is a web form for people to submit requests to engage a project on the cluster. We haven't publicized that yet because it's not actually open for business yet, but that will be publicized to the Orange County community once we're ready to go. And again, there is a governance board at Chapman, so it will be governed by staff at Chapman once, again, the keys are turned over. But we do expect that this will be a community resource, and we expect that we expect to get a lot of requests that don't really require a supercomputer, and we're going to try to weed those out.
So just a footnote on that is from a technical standpoint to address that, right? Some of the aspects of Run AI software allow us to give RBAC-like features into this cluster to allow the governance board to control things. So we can set up domains of experiments and things of that nature, data science teams, things like that. However, what we are not going to be doing is an RBAC system. So we're not going to be having a Coke Pepsi dual hosted situation. I don't think the cluster really calls for that. But the run AI part will drive 90% of what Michael needs to accomplish with the governing board and all that with the technology we have.
The question was, where is it going to be publicized? And certainly we will advertise that through our meetup site here, but also on the Chapman website. And we'll find through our partners at CLAOC, they have partners as well, and they're one of the drivers of this whole project. So they will reach out to all of their partners and publicize it. So we'll try to get the word out through all the social media contexts that we have.
The unspoken sin of all this stuff is documentation, right? Everybody loves doing documentation. I hate it too. But I've been doing documentation, and our team has been doing documentation as we've gone through this cluster and been building it. So I have a fairly robust corpus of how-tos, things of that nature, that would be relatively easy for the governing board to either take control of or insert accordingly and operate that way. Whatever Chapman does on their end of it, we merely look to serve and augment that existing process. But that stuff comes part and parcel with operating something like this, because nobody knows how to do it the first time. You got to learn, right? So.
And Ace, I mean, going back to your point too, and Ace, you bring up a great question. The enterprise folks are dealing with that same challenge. Who do I open it up to? How do I govern this? How do I charge back? What are all the costs, right? All these things come into fruition. Not only do you have to technically build a very sound cluster, but then all these other aspects start coming into play, which Chapman's going to try to manage the best that they can. The one thing that, again, Run AI does a great job, and Doug says this all the time, is that shame back, show back. Not so much in the Chapman use case, but enterprise-wide of like, hey, I'm going to let you on here. I'm going to give you a couple of GPUs. Business unit, I'm going to start charging you for that. And now IT now becomes a streamline for revenue, right?
In our company, if I don't do my expenses in a certain time, I get an email. The whole company sees who didn't do their expenses. Shame back. Same thing. That's what we're going to do.
And then Doug submits his expenses like that day. So it's great.
So the question was, do we consider Ray at all with this project? So for this project, we went Kate straight up. They already have a Slurm cluster. I think so anytime I look at students and that kind of stuff, that's this forum, I want exposure to new things, the beginner mind, right? And so Kate's is a perfect realm. Kate's drives 80% of all HPC stuff in. So let's deal with the foibles and the challenges and address it properly, which is what we're doing.
But why not Ray?
Because it's 80%, right? It's almost like, hey, what about rocks, or what about any of the others, right? They're very, I would consider them to be very industry specific when you start thinking about like media and entertainment or something. When you're looking at those data sets, this is the maximum flexibility that we can have to encompass whether we're going to do community-wise, with the board, with the education, whatever the curriculum may evolve to. Next year it could be a completely different set of curriculum classes, or however that changes at that level. Yeah. This gives the flexibility, in my opinion. Now, with that said, I will say also from a technical standpoint that there are aspects of a project I alluded to in the beginning around bureaucracy that are involved with donations. Yeah. And when you are begging, it's difficult sometimes to get the best of what you want to accomplish. I'm not saying this is the case here. I'm just saying that sometimes it's another dimension to think about. Yeah. It's funny. I get questions, and there's absolutely, it's organizations like this, right? The Room. We address questions on clusters like this from all aspects of the organization. The CEO asks questions, and the janitor locking the door asks questions, right? And it's difficult sometimes to mold and shape and address folks' questions correctly when you're up and down the stack and left and right.
And it's a novel architecture.
Yeah.
Something like Slurm is a lot more conventional.
Yes. I would say Slurm has done some amazing things in the last couple of years, but you're right, it's relatively baked. I would say it's straightforward. but it's purpose-built for data science. CATES is not. CATES is the service mesh framework. It's a completely different model. Great question. Thanks for bringing that up. Have we published benchmark numbers? I have an email from Katie, right? Christina, I'm sorry. Email, right? I don't have your smiley face in my email. Asking that very same question, okay? And maybe it was you that asked her, and it's finally coming home to roost. So what I'm going to do is there is a framework called the ML Commons, which has, good or bad, evolved radically. I'm going to run a couple of benchmarks from there. I'm not going to do anything theoretical. I'm going to do practical. We're having some challenges right now with some of the software that Dell provided in getting it to communicate properly for this cluster itself. We're iterating through those challenges. Now, part of the challenge that I have is I don't have a dedicated team on this project right now. I have, one guy is working 80 hours a week on other stuff, and I'm like, can I get a half hour to do this? And then I'll do this other, or I got another guy, right? So I'm kind of part project manager a little bit, which is fun, thanks. But I will be running ML Commons perf numbers for this cluster and getting whatever teraflop, petaflop, whatever it's going to be, flop numbers, and then they will be published in the documentation. So it's going to take a while. I was going to email you over Christmas or something. I think I got sick or whatever. Sick of this. No, I'm just kidding. A comment on that is interesting because I had talked in the beginning about a stress test on the thermals. Can the room support it? We ran a stress test thermally, and it worked great. The room could handle it. The HVAC kicked in, all that. I got an email from Philip, who I don't think is here tonight. Is he? He didn't show up. So I've been working with Philip as my liaison kind of on the infrastructure side. And he said one of the systems is just screaming. So I got to troubleshoot that now, right? So this isn't, it's not like a car or an engine mechanic. It's more like an F1, right? And so just because you're a tire expert, you're not necessarily the header expert on the valves and stuff. So there's a little bit of that I have to invoke. It's a team effort, right? Both with Chapman and for our team to bring this stuff together. So it's mostly a time constraint at this point. But yes, I will get perf numbers and we'll be able to publicize somewhere someday. This is a X point Y flop something.
Matt's here. We hired Matt. He was the VP of Analytics for the Anaheim Ducks for several years. I know there's some Ducks people in here. But Matt's here too as well, and he can give you some use cases around what they had done and what they're trying to do from that aspect.
Yeah, so. I won't keep you much longer. All to say that no matter where you are in your journey, I mean, Doug talked about everything from networking to storage. No matter where you're at in your journey, we'd be happy to have a conversation with you about all the pieces needed to get to what Doug just described. So happy to chat afterwards. That was it. Thank you all so much for having us and for coming out tonight.